our colleagues in the Business Analytics program, Michelle Lee, who's the director of the Master of Business Analytics program, along with a professor in the Operations Research Group, Alex Jacquelot. And we're going to go through a few slides today to give you an overview of how the curriculum is structured for the Business Analytics program, and then have Alex share a bit about the course that he teaches, and then we'll take some Q&A towards the end. So if you can hold your questions for a few minutes, and then when we let you know we're ready to start, you can type into the Q&A function. All right, go on to the next slide quickly. And just before I turn over to Michelle, I think it's always important to give a quick update on how things are being handled on campus this fall. So the Business Analytics program, along with all of the other graduate programs at the Sloan School, are on campus this fall. We are fortunate to have a lot of infrastructure in place, and we're able to teach both on campus and virtually in what we're calling a high flex format or a hybrid format. We do have a lot of social distancing guidelines in place, yet all students are able to take classes on campus and in person should they so choose. And the great news is for the Business Analytics program, all 60 students are here with us on campus this fall. And as guidelines continue to be updated and government regulations continue to come out, we will update our plans for the spring and for next year. But at this point, we have a plan through the end of this fall semester in this high flex format. So now I'd like to turn it over to Michelle, and she's going to talk to you a bit about the curriculum for the Business Analytics program.
Thank you, Jen, and welcome everyone. So great to see over 200 people here with us today. And thank you, Jen and Giada, who's also on the MBAn team, for being here, and Alex, of course, and Kayon from admissions. So please feel free to type questions and we'll try our best to answer them as we go. I see we've already received some questions, but we have a pretty packed schedule today. So I'm just going to take you through the overview of the curriculum, and then Alex here can answer questions specifically about his class, the Advanced Analytics Edge. I'm sorry, there's a typo in this slide. We actually changed the 15071 to 15072 and made the course more advanced. So Alex will be talking about that class to you today. But as you can see, this is a pretty packed schedule. Our students have 12 months on campus, and they take the required core, which you can see on the left-hand side, and they take other core classes during independent activities period, which is taught in January. Then in the spring, they take electives of their choice, 27 to 48 units, which translates to 3 to 4 classes. And at the end of the summer, the students graduate. It's a September graduation date, and most of our students start working right away, right after graduation. Students do have to maintain a GPA of 4.5 out of 5.0. At MIT, the GPA system is slightly different. It's a 5.0 scale, which means a 5 is an A and a 4 is a B. So you do have to maintain a B+ average in order to graduate from the program. Here is the 12-month overview in more detailed timeline for this year. So all these dates are similar each year, and I just wanted to give you an overview of what each of the months are going to look like. So right now we're actually in the fall semester session, and the students are going through midterms at the moment. We had an orientation, and after midterms, the students will prepare for a final exam. Then in January, our students do a communication training and career boot camp, as well as the launch of the Capstone project class. I did a separate webinar about 2 weeks ago on the Capstone project. So if you want to refer to that other webinar, feel free to do so. We talk about the class in much more detail. Then in the spring, the students take classes starting in February all the way until May. There's a Capstone internship, which is in the summer. And students also work on the Capstone project during the spring semester. And then at the end of the summer, the students graduate. And then this is just a list of all the courses the students have to take. by numbers. So at MIT, all courses are numbered. So you can see 15 dot some number means it's a cataloged course at MIT. 15 is the course name for the business school, which is MIT Sloan. But some of these courses are also taught cross-listed in the catalog with the engineering school. But you can see all of these courses are a 15 course. And these are the numbers. So if you go into the MIT catalog, you can actually just research the courses on your own. Now, the credits mean the number of hours approximately that the students will be working on the class per week. So for example, in Alex's class, students are expected to invest about 12 hours per week in the class. And he can go over whether or not this is true, but this is the guideline from MIT. And so on average, if you're taking 5 classes in the semester, you're averaging about 50 hours of 50 hours of time in class and doing homework per week. Okay. I just wanted to give you a snapshot of our technology. So this is what it looks like for our core classes. Our students use a platform called Canvas, which is used across the institute. And students will have these courses and deadlines on the right-hand side, and they will know what is coming up and what classes they're enrolled in. So I wanted to go through each of the core classes. The first is machine learning. This is a 12-unit class currently taught by Dean Dimitri Bertsimas, and it involves modern optimization used for machine learning techniques. And I won't read the slide to you, I'm sure you can read, but it's a very advanced PhD level course where they're using the most cutting edge research to teach you non-heuristic based approaches to ML. So you can see students will work in groups and work on problem sets, and there's also a midterm and a final exam. The next course is Alex's course, which is Advanced Analytics Edge. In this class, they use real live examples with case studies in e-commerce and healthcare, in technology, and students also form teams to work on a real project. They have to find their own data sets, and they use techniques that are taught in the class, like linear regression, classification trees, random forests, and they take those techniques and really showcase their work by doing a group project. The next one is optimization methods. You can see here it's cross-listed with engineering. The course is a typical optimization course. It follows a really academic textbook optimization progression. So you can see from linear optimization to discrete to nonlinear. And also this is a PhD level course. You will be taking classes alongside engineering school students. There are numerous problem sets and deadlines along with a midterm and a final exam. This is one of the hardest courses in the curriculum. The next core class is Analytics Lab. This is a project-based course. It's less academic. They have industry speakers coming into the classroom to give talks about what's happening in the corporate world. And they also have teams that match with businesses, real businesses during the semester. And these teams are 3 to 4 students per team. They range from, like LinkedIn to Gates Foundation. They've done projects with local transportation logistics companies, as well as healthcare and social media and marketing companies. It's a really cool hands-on project. We call it a laboratory, where we use mind and hand together to learn from the real world. And then the last fall core course is From Analytics to Action. This is the most business school-like course in the curriculum. They will talk about organizational context in the real world in relations to analytics. They will introduce dynamics and dynamics in the corporate world, as well as negotiation techniques, ways to solve corporate strategy using real life case studies. So this course is very interactive, and it's also not graded on a 5.0 scale like ABC. It's a pass-fail course. So either you pass or you don't. And then the last class is the Analytics Capstone course, which Alex is also involved in because he advised several of these projects last year. So this is the required 24-unit course, which spans January until August. It's the last of the core after all the other courses, which are taught in the fall. This is taught starting in January. And faculty advisors are paired to groups of 2 students, and they work on a project for 7 months. So in the spring, they work on it part-time, about 10 to 12 hours per week per student. And in the summer, it's a full-time obligation. These are some sample projects from the capstone, and I did go through this in more detail, as I said, in the webinar 2 weeks ago, so you can refer back to that. But these are, I just wanted to list some of the examples that are brought into the classroom for our students. And here are some of the partner companies that we partner with. So all different industries, sizes, even government, like the United States Postal Service, to startups, and anywhere from retail to healthcare to transportation. And then I'll briefly touch on electives before I turn it over to Alex. So the students can take a number of electives during the 1 year at MIT. These are just some examples. And students can also take classes at Harvard through cross-registration. So we have an agreement with Harvard where Harvard students can take MIT classes and MIT students can take Harvard classes. And these are just some examples of classes our students have taken in the past. And these are approved for a graduate school level data science curriculum. So in the fall, the students take a maximum of 12 units, and in the spring, a maximum of 48 units. You can take more units if you want to as a listener, which means you're auditing the class, but the number of units that is allowed are 48 in the spring and 12 in the fall. And then I welcome you to visit the course catalog. It's a huge site where you can browse all the courses offered at MIT. So oftentimes new courses are added every year for MIT students. And if you find a course that is graduate level that is related to analytics and data science, certainly students can propose those courses and they can be approved for you to take. Okay, so now I will hand it over to Alex to briefly talk about his class, and then we'll take questions.
Thank you, Michelle. Hi, everyone. Nice to virtually meet you. So I just wanted to spend a little bit of time talking about what we're doing in this in the program, especially in this Advanced Analytics Edge class, which I think is kind of representative of what you're going to learn in the program. So I started actually replying to some of your questions already. So basically, my take on the program is that we're bringing together various facets of analytics into a unified curriculum. And we're really trying to bring together the questions around data management, visualization, predictive analytics for machine learning, and prescriptive analytics for optimization to really close the gap from data to decision-making, right? So data, prediction, insight, decision-making, which is really the kind of the end-to-end view that we need to make a difference in business and public policy through analytics. So as Michelle said, I mean, I'm just going to repeat slightly differently, is that in the core, you have the machine learning class, you have the optimization class, and then in Analytics Edge, we can do the application of both. And so we start by reviewing all the data mining methods. linear regression, regularized regression, logistic regression, regularized logistic regression, support vector machines, trees, random forest boosting, deep learning. And then we do, for each of them, we do a pretty advanced case study in order to understand not only how the methods, the algorithms and the mathematics work, but also how to apply it and how to ask the right question when it comes to building the right model beyond building a model correctly. So that's kind of the philosophy of Analytics Edge. And then we do the same thing for optimization. So we review linear optimization, multi-objective optimization, large-scale optimization, and stochastic optimization for decision-making under uncertainty. And then we cover a few more advanced methods in machine learning, like natural language processing, principal components analysis, and so on. An important part of this course is a term project. I view that as a very low stress environment in order for you to have fun with a data set and a predictive problem that you, or prescriptive analytics problem that you find interesting. And like really spend a month to explore an impactful problem in data-driven decision-making that you find interesting. So we are currently working with the current cohort on designing these problems, but it's already extremely broad. So we are going to learn how to predict the outcome of tennis matches and designing a gambling strategy. We are going to learn how to rebalance shared bikes from dock to dock in order to make sure that you always have bikes available when where people need them. We're going to work with housing data set in order to see how we can predict evictions in the post-COVID world and understand how we can alleviate the social implications of evictions. We're going to work with anime data set in order to understand how to be a recommendation system for people. We're going to learn with wildfire data set in order to see how we can predict what is going to be a very severe wildfire versus a less severe wildfire to enhance firefighters' ability to combat wildfires, which is obviously in the news very frequently right now as they are having an impact in the western part of the United States. So all of these examples show the diversity of what type of case studies we're doing in this course and how we are using a variety of analytics methods in order to solve important problems for management or public policy. And I also view this course as like an important part of the broader curriculum. It's an important core course, so people also build a cohort during this course. And then we revisit these themes throughout the program. So first of all, during the fall semester, there are a lot of interactions between the machine learning course, the optimization course, and the analytics edge course. And we have a kind of in-depth discussions with several students to try to understand how is that what we're learning in one course applicable in another one, and what is the relationship between this method and that method and these type of things. And then as Michel mentioned, as we're moving toward like the capstone projects, we also try to think a little bit more systematically about how to think comprehensively about everything that we're learning in order to solve like a real world problem in a longer time horizon, like 6 months. So this is a brief introduction. I'm more than happy to answer questions at this point in order to make this a little bit more interactive. So feel free to send any question my way. Jen and Kayan, if you have any question that I should answer, I'm happy to take them. And otherwise, I can keep talking and provide more details about the course or the curriculum or anything else, or the research that we're doing at MIT as well.
Thank you, Alex. We have a number of questions in the chat. One of the questions relating to grading here is, how are grades scored and is the grade curved? Do you want to answer that for your class specifically?
Yeah, grades reflect student performance, period. And then there are different ways of implementing that. I don't grade my curve. I don't grade my grades. I don't curve my grades, excuse me. But grade reflects student performance. Students are amazing and students get good grade.
Wonderful. And then because I know you recently came from a different university where you taught prior to coming to MIT, could you maybe talk about how this curriculum is different to other data science or Master of Business Analytics programs offered at other universities that you've seen?
Yes. So here I think I replied to one of those, but what we are really doing, I think, in this program is bringing together different facets of analytics into one comprehensive and integrative curriculum. I don't think that there are a lot of programs that have the same scope as the one that we do in such a short period of time. Learning everything from the predictive machine learning methods all the way to the prescriptive optimization methods in such a short period of time is quite unique, I believe. There are a lot of data science programs. I mean, every university has one basically, but usually there will be a little bit more focused on the predictive analytics part with machine learning and data mining courses. Here, it's an important part of what we do. It's not the only one. And at the same time, you're going to learn quite a bit about all the decision-making layer of what we're doing, which is how to translate predictive insights into prescriptive decision support tools. And the other one is, to be successful with this, you need to understand the technical components, but you also need to understand the business components, right? You're graduating with a business analytics program. So, and I think that we're emphasizing a lot the interface between the technical components of analytics and the business components. And this is another theme that we're finding through the curriculum.
Thank you. I have another question here from Elizabeth Guan. She asks, what are some of the most impressive capstone projects or other projects in the classroom that you've seen? So can you give some examples of cool projects that you've advised or graded students on?
Yeah, I'll give some examples from last year because the projects are completed. So there are a few things that really stands out. First of all, I've been really amazed by the students. So I'm going to talk first about my term projects in my class, okay? And as I said, it's a very low risk environment for people to really find impactful projects. And last year we were, looking at like fairness and bias in policing decisions in the Bay Area, which was, again, a very important public policy concern. Another one was actually something around housing evictions, which became extremely important in the COVID crisis. We looked also at a range of problems around climate change analytics and how we can combat climate change with various parts of what we're learning. And the interesting part in this world is that we're really looking at kind of targeted business problems sometimes, but we're also looking at like very broad societal questions at the same time, and that's really what makes this very exciting. Another example of things that stand out is projects that look at a question, but go very deep on the technical side and develop amazing methods. And last year we had a few of these projects of teams who took on a Kaggle competition that had to do with predicting the outcome of plays in American football. And they developed like really amazing methodologies for that we're not only applying what we had covered in class, but also expanding it. So turning it into a research project in a sense. So that's number two. And then in Capstone project, I mean, I've been fortunate to work with great teams. So one of them is we worked with Starbucks last year. That was very interesting because we were using Internet of Things data with very, very high granularity. So every time a Starbucks barista is pressing a button in order to make an espresso, this is an entry in my data set. Right. So you end up with millions and millions and millions of records, and you have to find ways to aggregate that information in order to retain the signal and not just noise. Very interesting methods that we're that were developed there, but also very interesting work with the data science team at Starbucks in order to transform like a good algorithm into an actual software that is currently being used. So seeing also all that impact at the end of the day is very insightful.
Great, thank you. There's a number of questions here from Morale and from Christina about prerequisites for your class and the program. What are some skills, technical skills or prerequisites students should have before they come into your class?
I mean, that that may be a question for you as well, Michelle, in terms of prerequisites for the program. For me, it's very easy. If you're admitted into the program, I trust the admission committee. But basically what we need is, what we want is people who have good technical background and understand mathematical notation and algorithms and have that type of thinking. We don't need to be like wizards in linear algebra to be successful in the program. We need to have a good familiarity with these concepts, and then we need to have the curiosity of actually doing applied work and impacting business and policy. So basically, I think that the people who are sometimes struggling a little bit are people who don't necessarily have the right mathematical background on the one hand, or people who are perhaps a little bit too technical on the other hand and want to do at the end of the day computer science as opposed to business analytics. Anything in between, I think, would be great.
Thank you. Yes. So generally, we have, if you have a basic knowledge of linear algebra, as Alex said, and some computer programming, that should suffice for enrolling into the program. However, this is a very competitive program. We have over 1,000 applications each year. So we typically take the strongest applications with students from, you could be a business major or a non-business major, but we just want to see that you have strong interest in data science and analytics. And the more technical skills you have, the better. But there is no cutoff or minimum requirement.
I'm seeing also a couple of questions about the research, and let me say a few words about this. First of all, a lot of students who are enrolling have an interest in joining one of our teams as a research assistant. Most professors have opportunities. Obviously within limits, right? So everyone doesn't necessarily find the right project, but most people would do. And it's really something that I think is attractive, which is like we're trying to blend the research into the teaching, and then we're trying also to use the teaching as a way of developing new research ideas with the new cohorts of students. So I'll give you a few examples. We are right now, I'm doing one project on early childhood education, where a company has very interesting data sets on the topic, and we're trying to understand, hey, is there something that we can actually make sense of using this data set? And so I'm working with one MBAn student who is basically doing that in parallel to taking Analytics Edge. One way to think about it is that he's doing a capstone during the first semester with me on that topic, basically. So that's also a very good way of like actually getting your hands dirty, and at the same time thinking about kind of open questions and actually developing your own thinking, as opposed to just doing homework to homework. The difference perhaps, yeah, exactly. So basically what research is in that sense is that you're asking the questions and answering them at the same time, as opposed to like following a prompt. And then obviously another example here is that, for example, with Dimitri Betsimas, we have worked quite a bit on various aspects of COVID analytics. And that's also something where we are very fortunate to work with amazing MBAn students. So how to use data in order to predict the future of the pandemic, but also how to use these models in order to optimize the allocation of resources to combat the pandemic most effectively. And vice versa, whatever we do in research, we try to bring into the classroom. So we bring examples, but we also bring new methods from that research.
Thank you, Alex. I see a number of questions here also about electives. I just wanted to cover the electives briefly again. So students can take one elective in the fall and up to 48 units or 4 electives in the spring. And these are just some examples on this slide of the electives that students take. So they can be business school electives. For example, you can take power negotiation, which is a very popular business school class, or you can take a very technical engineering school class like advanced topics in artificial intelligence or statistical learning theory. So it's really up to you, but there is a list of approved electives that our students take, and it can't just be like, you can't just take cooking or you know, psychology as a data science elective. It has to be graduate level and related to analytics. I did show a slide here before of other electives that students have taken, and I just mentioned that you can also take electives at Harvard through cross-registration.
In terms of elective, what I usually recommend to students is having for the spring, having a mix of technical and business courses. So a couple of students use the elective in order to go deeper into some of the methods that we are not necessarily covering too much in the core. Examples, reinforcement learning. So I've had like my capstone project team was taking a reinforcement learning, and they were actually playing with robots like every week and like programming robots and so on. They had fun with that. Another one is natural language processing, which is very popular, which we only briefly touch upon in the core. And at the same time, I think it's also a good opportunity to go a little bit deeper into one or two of the, let's say, business domain that you're interested in. Michelle mentioned negotiation. You can take a course in operations and marketing, in finance, or something like this. Again, you have a degree in business analytics, and it's important to be able to be very fluent in the analytics component and in the business component.
Mm-hmm. Great. And then I see a question about the data trek. So we do offer a data trek in the spring. Typically, we take students to California and to Seattle, Washington to visit tech companies. During the pandemic, we are not able to travel. So as soon as the pandemic ends, or hopefully the travel restrictions are lifted, we do plan to take our students to the West Coast. But for now, there is no travel that's being authorized by MIT. In fact, students are taking classes twice per week in person, and then the rest of the days of the week, they're taking courses online right now. Typically, there is no online option for completing this master's program, but we're in a special situation at the moment with the pandemic, and students are taking classes online. But typically, this is a in-person full-time program where students are expected to be on campus. Let's see.
So I see a few questions about programming languages. Let me say a few words on that. Programming languages are the means, they're not the end. They are here in order for you to translate your technical knowledge into actual solutions. There is, depending on exactly which company you're working for, or which project you're working on, or which team you're working with, the norm can be slightly different. Today, I would argue that the hardest one is Python. And most people will use Python for their capstone projects, for example, in the MBAn program, but this changes over time. Yesterday it was R, tomorrow, who knows? Julia is becoming very popular as well. And I view an important part of what we're doing in this program as building multilingual analytics professional, meaning people who can not only program in one language, but maybe 2 or 3. And actually, most people end up being very comfortable with Python, R, and Julia. For example, in my class right now, we're using R for the machine learning part. We're using Julia for the optimization. people learn Python in another class and they use Julia and machine learning, right? And so at the end of the day, I think it's really important to know all of that because each program will have some different strengths. R is very good for statistical learning. Python is very good for computer science-based machine learning, and Julia is very good for optimization methods. And it's important to have the flexibility in what you can use. So I wouldn't over-index on that. As long as you have some familiarity with one programming language, we'll find ways to make it work here. Elizabeth, as a Californian, you're interested in how we can fight wildfires. Yeah, so we have a project right now which is trying to predict the magnitude of a wildfire at the time of inception. It matters a lot, right? Because usually when we know the magnitude of a wildfire, it's a bit too late. And if we can actually do early prediction, early detection and prediction, we can make a big difference. There is another question, which is when you have a limited, so that's a prediction problem. Then there's an optimization problem, which is you have a limited firefighting force and you have to make prioritization. It's like a hospital having to make triage decision at the heat of the COVID crisis. So how to do that? And here you have another thing, which is that the fires are not equally distant, right? You have some that are very easy to get to, but some that actually require like 3-hour travel in order to get there, and that is like much more expensive. So you need to actually do some complex optimization in order to understand how you can best combat the wildfire crisis with the resources that you have and the information and the data that you have. So we're actually starting to explore this question as well in research. So hopefully you can join our team next year. For Analytics Edge, and more generally, do you dive deep into the mathematical theory, or is the idea just to get the general intuition behind models regarding the short period of time? I would say both, and it depends. But overall, you will go into like the mathematical dimension of what you're learning. We don't want to just say, all right, this is roughly how it works, and then trust the algorithm and get the solution, because we want you to understand what is behind that. That being said, it's not a program that is just doing theory, and it's a program that is doing application, and so we also want to keep track of that. So I would say that there is a decent amount of theory. For example, in Dimitri Bertsimas's course, Machine Learning, that would be like a more theoretical course than Analytics Edge. In Analytics Edge, we do more application, but I also cover like the underlying algorithms. And to really understand that, you need to be comfortable with the theory. What are your favorite analytics methods to teach? Do you touch on technique you use in your research on airline optimization? Oh, my favorite analytics methods to teach. I love teaching optimization because that's what I use most in my research. But I also love teaching about ensemble methods like random forest and boosting, because they're very black boxy when we don't understand them. But then once we understand them, we can really make them simple and interpretable. And I really like that journey. And yes, as I was saying before, we're trying to bridge the gap from research to teaching and back to research. Very interested in learning more. Sorry, I'm just taking the questions. Stop me when you want to. Very interested in learning more about research project that focuses on creating social impact. Could you please give us more social impact project topics, examples that students will encounter and work on in this program? So first of all, bring your ideas. We always want ideas, and term projects are here for that. Then in research, we have several questions that I think have social dimensions. I mentioned COVID analytics. That's something that I've been working on with Dimitri Bertsimas. Professor Recep-Levy is also working a lot on that. Professor Recep-Levy and Karen Zhang have a lot of work on agriculture, especially in developing countries, food supply chains. I'm working on, so again, I mentioned wildfires. I'm working on education. I'm working on smart cities, smart mobility, equitable access to transportation, right? So all of these, I think, have an important societal dimension. And then I mentioned more generally like climate change analytics, which is becoming increasingly important. So if you come with that interest, I think that MIT would be a good home for you. Dimitri Betsimas is also creating a new class for undergraduates that is around analytics for a better world, and that's really a theme that we're trying to develop as part of this program and as part of our research endeavors.
Wonderful, thank you. I see some questions about career paths and what students pursue after this degree. So typically most of our students go on to become data scientists in the industry. We do have 1 or 2 students going on to pursue a PhD within the Operations Research Center at MIT, but those are usually 1 or 2 per year. The rest of the students find jobs during either the spring semester or the summer semester. And we've had students go on to companies like Facebook, like Google, Apple, Amazon, startup companies in New York City, real estate, fashion, healthcare. So you name it, the students, it's a very diverse range of industries. And we help students with a full suite of career development resources. We help you with your resume preparation, your LinkedIn profile, as well as negotiating your offer letters when you do receive them. Also, some students want to know if there's a summer internship. There is a mandatory capstone project, which includes this 10-week summer work experience with the capstone companies, which we talked about before. Alex advised on Starbucks, and Starbucks had 2 students last year work in the summer for a capstone project. So it does include a full-time guaranteed summer work experience, and students are compensated for that. The students are granted tuition of up to $22,000 to complete their capstone project, and there is a smaller summer housing stipend reimbursement up to $5,000. So it's quite lucrative and really beneficial for both sides. Any other questions that we haven't covered? I think we covered a lot of these.
Yeah, so SQL, will that be taught and utilized? I think that there is a short course on database management in SQL. It's not core like most of what we do in the program. We typically do like more of like the downstream analytics, but we try to cover the upstream data acquisition and data management. So there is some SQL. I think that the best way to learn SQL is actually use it, and people actually end up using it quite a bit during the capstone projects. I've seen a few questions on MBA versus MBAn. Jen, do you want to take that one?
Sure. So the MBA program is really geared towards individuals who have a minimum around 4 or 5 years of work experience. In addition, it's not going to go as deep technically as the business analytics program does. Students who are interested in analytics type roles can pursue the business analytics certificate as a part of the 2-year MBA program, but the Master of Business Analytics program is really a deep dive in analytics and technical training. I also see a few questions here about research opportunities or opportunities for research assistantships. Maybe Michelle, would you like to take that?
Yeah, sure. So we do offer research assistantships once a student is admitted to the program. It is competitive though. So this year we had 60 students and a number of those students, I think 40 some students applied for a research assistantship, and about 50% of those students were accepted for research by a faculty member. So about 20 of our students are doing research. The research requires that you work 10 hours per week during the fall semester, and if your research assistantship is renewed in the spring, the same thing. And then the students would do research alongside the faculty member. There is a standard payment for research is something around the order of $10,000 per semester, which goes towards your tuition, and there's a stipend portion. So it is very competitive because of the financial aspect to the RA-ship, but it's also really good for your experience and your resume, and to have potentially published a paper with a MIT professor at the end of your research term.
All right, I think that we've covered the majority of these questions today. I'd just like to thank everyone for joining us today to learn a bit more about the Business Analytics program. We will have a version of this posted online within a few days, along with, it is, I believe, already posted, but along with the webinar we did 2 weeks ago about the Capstone project. So check our website for those. They're also linked through YouTube and you can find it there. Michelle and Alex, thank you so much for joining us. Giada and Kayon, thank you so much for answering all the questions behind the scenes. We invite you all to continue to join us for future events. Business analytics specific events are held, every 2 weeks or so. Check the website for more details. And we look forward to getting to know you all much more throughout the application process. So thanks so much. Have a great day.
Thank you.
Bye.
Bye.